To find the total number of zeros a polynomial has, we're going to use something called the fundamental theorem of algebra, which sounds very complicated, but it's actually very simple. Turns out that whatever your degree is, your highest exponent, that's how many solutions you have. So, for example, in this polynomial, our degree is 3, our highest exponent is 3, so it will have 3 total zeros. The second polynomial, my degree is 6, my highest exponent is 6, so it'll have 6 total zeros. Now, those total zeros, some might be real, some might be imaginary. Some of them may be double or triple solutions, so we have to be careful how we count them. So let's go ahead and actually look at some graphs to figure out a little more specific, because total number of zeros is easy. Let's be a little bit more specific with that. And so here are 3 polynomials that we want to say not only the total number of zeros, and remember number, we're not actually finding zeros yet, just how many there are, but we also want to be more specific and say how many are real, how many are imaginary. So for your total number of zeros, I've gone ahead and filled this out already, but let's talk about it. Total number of zeros is your highest exponent. So there's 4 total, there's 5 total, and there's 6 total. The only way to find out how many of those total are real is to actually look at a graph. So I've gone ahead and already typed my first polynomial in. If you need to pause the video and type it in for yourself, do that. But taking a look at the graph of that actual polynomial, the way it will tell me how many of those total are real is I want to look for x-intercepts. Every time the graph crosses the x-axis, in this case 4 times, each one of those represents a real solution. So there are 4 that are real because I see 4 x-intercepts. Well, if there's 4 total and 4 that are real, that means none of them are missing to be imaginary. The imaginaries will always be the missing ones that we're not seeing. Okay, so let's try to take a look at this second polynomial. So once again, we know it already has 5 total zeros because that's my degree, but the only way to figure out which ones are real, how many are real, is to look at the graph. So here's what the graph of this looks like. Again, all real solutions will show up as x-intercepts. So this graph crosses the x-axis 1, it's hard to see it there, but 2, 3 times. So there are 3 real solutions. I could zoom in a little better if I want to see that better. If there's 3 that are real and there's 5 total, 2 must be missing that are my imaginary because they have to add up to a total of 5. Okay. Finally, we have this last polynomial to look at. We know it's got 6 total zeros. Oops, let me turn off that one and turn on the one we want. So we know it has 6 total. The only way to test for how many are real is to look at the graph itself. So I want to look for x-intercepts, and this time, oh, I don't see any. There are no x-intercepts on this graph, meaning all 6 of them must be imaginary. All right, and the last thing we want to take a look at is double solutions. So we've looked at how to find how many solutions are real, how many are imaginary, but let's look and see what happens when we have a double solution in the graph. So here's a long 5th degree polynomial. So we know it's got 5 total zeros. Let's take a look at what the graph looks like, because remember, the graph will show us which ones are real. Every time we touch the x-axis, we have 1 real solution, unless something special happens. So there's my graph, slowly getting graph. Looks like I don't have a great window because I can't see that minimum, but that's okay. So I see 1 x-intercept right there, and it appears a second one right here. So I would guess that there's only 2 x-intercepts, but I put a total of 3 down. It turns out that anytime your graph comes and bounces off the x-axis, anytime it like skims the surface, that actually represents a double solution. And so for the fundamental theorem of algebra to work correctly, we have to count that as 2 solutions. So this graph actually has 3 real solutions, 1 right there, 2 of them right there for where the graph bounces. Even though it's the same solution, we count it twice. So there are 3 that are real, meaning that 2 are left over that are imaginary. And you'll notice that this question also asks us to find the actual coordinates of the zeros. I'm going to say that for the next video. So for this video, I just wanted to talk about how to find the total number, the real and the imaginary number of zeros, as well as bouncing and all that. Watch the next video if you want to see how I found these using the graphing calculator.